Hi, hello everyone. We are going to continue with one more problem. So that is a solid shaft. Okay, a solid circular shaft has to transmit a power of 1000 kilowatt at 120 RPM. So find the diameter of the shaft if the shear stress of the material must not exceed 80 Newton per millimeter square. Shear stress is 80 Newton per millimeter square. The maximum torque is 1.25 times the mean torque. What percentage of saving in material would be obtained if the shaft is replaced by a hollow one? So initially it is solid. So after what percentage of saving material would be obtained if the shaft is replaced by a hollow one, whose internal diameter is zero point 0.6 times the external diameter. Okay. So zero point 0.6 times the external diameter, the length, material, maximum shear stress being same. Okay. So this is the problem. So it is little bit lengthy, but very easy. Okay. Don't worry. We'll solve this problem step by step. Okay. So solution. First, list out the data which is given in the problem. So P is 1000 kilowatt, which is given. So N is equal to 120 RPM. Tau, shear stress, 80 Newton per millimeter square. So maximum torque is 1.25 times the mean torque and internal diameter. Okay, so internal diameter is equal to zero point 0.6 times the external diameter. Okay, so that is also given. So here, so internal diameter is zero point 0.6 times the external diameter. That is di internal diameter is equal to zero point 0.6 times the external diameter, outer diameter. Okay. So now we need to go through the problem. First is power. P is equal to 2 pi NT by 60. T mean. T means per T torque means mean torque. So P here the denominator we have taken only 60. So here you need to multiply with 10 to the power of 3. 1000 kilowatt is there now. So 1000 into 10 to the power of 3. Again, I'm saying in the denominator, if you have taken 60, left hand side power, you need to multiply with 10 to the power of 3. Okay. If you have taken 60,000, only take 1000. But in this problem, I have taken 60. So in the left hand side, while taking the value of P, multiply by 10 to the power of 3. Coming to the right hand side, so N is speed is 120. T mean we need to find because maximum torque is 1.25 times the mean torque. So finding this, we are going to get the maximum torque. So T mean as it is, so do the cross multiplication. You will get the mean torque is equal to 79,577.47 Newton meter. So if it is in terms of millimeter, just multiply by 10 to the power of 3. That's it. 79,577.47 into 10 to the power of 3 Newton millimeter. So that is the mean torque. Now substitute this value in this equation. Okay. T max is equal to 1.25 times the mean torque. When you substitute that, maximum torque will be 99,471.87 into 10 to the power of 3 Newton millimeter. Now, after finding this maximum torque, next is to find the diameter of the solid circular shaft. That is the first one, right? We need to find out the diameter of the shaft. What is the diameter? So for that, from the torsional equation, T by J is equal to T by J is equal to tau by R. So from this, T is equal to just multiply, cross multiply tau into J by R. So tau is maximum. Okay, so because maximum torque means maximum shear stress you need to consider. So J is polar moment of inertia, pi d to the power of 4 divided by 32. R is radius, radius, that is d by 2. So d by 2. So here d and here one more d get cancelled. D to the power of 4 will become d cube. 2 ones are 2 16s are. Okay, just divide. So final equation will be T is equal to maximum torque will be equal to maximum shear stress multiplied by pi d cube divided by 16. Now from this, maximum torque. Okay, so we have already found maximum torque is 99,471.87 into 10 to the power of 3. So maximum shear stress is given in the problem 80 into pi. T we need to find, diameter we need to find, T cube divided by 16. So just do cross multiplication like this. Okay. So 80 into pi d divide. So diameter will be 185 mm diameter. Okay. So please do calculation correctly. So we are going to get d is equal to 185 mm. After finding the diameter, next thing is dimensions of the hollow circular shaft. Dimensions of the hollow circular shaft. So to find this, we are going to assume this condition. Ts is equal to Th. What is Ts? Okay, Ts is nothing but torque on the solid shaft. Th means torque acting on the hollow circular shaft. Okay, both we are going to consider as equal because the length, material, and maximum shear stress which is acting. So all are same for solid and hollow. That's why the torque acting on a solid shaft is equal to torque acting on a hollow circular shaft. We are going to consider as equal. Now from the equation, T, you already know that, right? So T is nothing but, so we are going to use this formula. What is that? T is equal to pi in d cube by 16 into tau. So that equation we are going to use pi 5 by 16 tau into d cube equals to. So this is hollow means you need to get two diameter, outer diameter and inter diameter. So pi by 16 into tau is same. So in case of t, it is replaced by d to the power of 4, d naught to the power of 4 minus di to the power of 4 divided by d naught. So from this equation, pi 16, tau gets cancelled. Remaining thing is d to the power of 3 in the left hand side. In the right hand side, you will be getting d naught to the power of 4 minus di to the power of 4 divided by d naught. Okay, so this is the equation what we have left out. So substitute the value. Diameter is 185. Okay, so for solid circular shaft, only one diameter d 185 to the power of 3 is equal to d naught to the power of 4 minus so here di. So in the problem, this they have given di is equal to 0.6 times the d naught. So this is what they have given. So just substitute the value of di as 0.6 times the d naught. So 0.6 times the d naught to the power of 4 divided by d naught. So from this equation, I'm going to take d naught to the power of 4 as common. So in the denominator, we have one more d naught. So this and one d naught will get cancelled. So it becomes d naught to the power of 3. So here 1 minus 0.6 to the power of 4. 1 minus 0.6 to the power of 4. In the left hand side, 185 cube. So that will be 633, 1625 equals to d naught cube into 0.8704. So from this, we are going to get outer diameter as 193.76 mm. After finding this d naught, just use this equation. di is equal to 0.6 times the d naught. D naught value, please substitute here. It is 0.6 times the 193.76, and you will get the inner diameter of a hollow circular shaft. So outer one is 193.76, inner one is 116.256. So these are the dimension of a hollow circular shaft. Inside diameter, outside diameter. Okay. Now, to find the percentage saving in weight, because first we have used a solid circular shaft, and now we need to replace with hollow circular shaft. So for that, this procedure we need to adopt. Ws is nothing but weight of a solid shaft. Wh is nothing but weight of a hollow shaft. Okay. So weight density, you already know that weight density is equal to weight by volume. So just cross multiply. So then we will get weight is equal to weight density into volume. Volume can be written as area into length. Okay. Volume is equal to area into length. So Ws is equal to pi d square by 4 into L multiplied by weight. So weight of hollow circular shaft will be equal to pi by 4 d naught square minus di square into L, area into length into weight density. Okay. So we are going to assume percentage saving in weight is equal to Ws minus Wh divided by Ws. Please remember, Ws is the weight of the solid shaft, Wh is the weight of hollow shaft multiplied by 100. So from this equation, substitute the value what we have considered. Ws is nothing but pi d square by 4 into L into W. So WH is nothing but pi by 4 T naught square minus Di square into L into W. Just substitute in this equation, okay? From this equation, pi by 4 L W. Pi by 4 L into W is common. So that will be cancelled with pi by 4 L and W. Okay. So in the numerator, it remains with d square, d naught square minus di square. In the denominator, it remains with d square. Okay. So now multiplied by 100. So d square minus d naught square minus di square divided by d square. So from the previous thing, we have already calculated the diameter of the solid shaft is 185 mm. So the diameter of the hollow shaft, where we have outer diameter and inner diameter. Outer diameter is 193.76, inner diameter is 116.256. Just substitute this value in this equation, okay? So we are going to get 29.79%. Okay. So percentage saving in weight, it is nothing but 29.79%. So diameter we have found out. Diameter of a solid shaft we have found out. Dimensions of a hollow circular shaft, because which is very much needed in finding the percentage saving in weight. Okay. So di d naught also we have found out. And next thing is percentage saving in weight when we replace it with hollow circular shaft is 29.79%. Okay. So we will meet again with a new problem in the next class. So thank you. So if you have not watched my videos, please go through my channel where I have uploaded several videos. Please like, share, and subscribe. Thank you.